Good afternoon, everyone, or good morning, and welcome to WebAid Solutions webinar on Kotlin. If you could, please use the control panel that you have and raise your hand. It should be next to your name. There should be a hand icon, and that way we just know everybody's has access to that control panel. I see a bunch of hands going up. Good, that also just verifies for me that you can hear my voice. So you can go ahead and put your hands down at this point as well. When we start, as we said, we'll ask everyone to raise their hands. If you have a question during the presentation, please type it into the questions section. And if you raise your hand, that'll help just bring it to my eye, and I will answer it either right away or when in context when we have the opportunity. If I'm not able to answer your question right away, I will take note of it and search out the answer and respond to you via email. After we're done with the presentation, shortly after, the slides will be available. I think it's in PDF format, and we are recording the presentation, so if you have colleagues or who might be interested in this, they'll be able to access it after the fact. So with that, let's go ahead and get started. We've got a pretty full agenda. Today we're looking at Kotlin, a modern language for Android development. And I have to tell you, my background, as I said, my name is David Chung with WebAid Solutions. Given my background, this is kind of an odd webinar for me to give. The reason is I've been a Java person since the very earliest days, back when Java was in beta. I took my first Java job as soon as Java 1 was released, and I've worked in Java in a number of environments, ranging from desktop applications to big SOA systems, server-side Java. I've even worked in Java in embedded systems in the defense and military environments, some aviation sorts of things. I'm currently working in microservices in Spring Boot and Java. So I've been a Java person all the way through. I've also done a fair amount of production Android, building Android devices, one for the consumer market and another that had an IoT and sort of machine control, sort of tying in with my embedded experience as well. So I'm a Java person, and in the Android world, I've been a Java person as well. But Kotlin is a modern language for Android development. And the more time I spend working with Kotlin, the more I appreciate the Kotlin language. So we'll drill right in and we'll look at some of those features that make Kotlin a compelling choice in the Android space. So here's where we're headed. We're going to take a look at an introduction to Kotlin, sort of a history, where is it placed and why. Then we'll look deeply into why Kotlin. Why would we choose Kotlin when we already have a first-class language with which to build Android applications, and that is Java. Then we'll look at some of the features of the Kotlin language, and we'll just briefly look at creating a Hello Kotlin World or Hello K-World app in Android Studio, targeting the Android platform. So that's where we're headed. Kotlin is the product of JetBrains. And JetBrains, founded in 2000, so they've been around for a while, is the producer of IntelliJ. IntelliJ IDEA has been around as an alternative Java IDE and alternative to Eclipse and others. The difference with IntelliJ is IntelliJ has always been a commercial product. There are free versions of IntelliJ IDEA, and Google switched to using IntelliJ as the basis for Android Studio rather than using the Eclipse plugin version to build Android. So that's been a big change. JetBrains is a Czech company. They've got a bunch of employees all over Eastern Europe and in the US and Boston. Why is it called Kotlin? Well, the name is based on the name of a city in Russia called Kronstadt. And they refer to it as Kotlin. So if you're wondering where the name came from, it's after Kronstadt in Russia. And JetBrains has a number of products. I'm actually a big fan, not just of Kotlin, and of course as an Android developer of Android Studio, but I use IntelliJ when I can, when my clients allow me to, for Java development, and I use WebStorm and PHPStorm corresponding with it for web development. So I've used a handful of their tools, very powerful tool set. So that's where Kotlin came from. So what is Kotlin? So Kotlin is a language, a modern programming language. It's statically typed. And one thing that these new languages coming out have to their advantage is they've come out more recently than Java, even than Scala, C#, Groovy. Kotlin is able to build on some of the best practices, or steal some of the best practices, best ideas from these languages. Now we're going to be talking about targeting Kotlin to the JVM, or ART specifically for Android, that is the Android runtime. But Kotlin is not just for Android. This year at Google I/O, Kotlin was announced as the first-class language for Android, but it also runs in the JVM, so it can run wherever you have Java. It can also target JavaScript and can also target native. Our focus here, though, is the relationship of Kotlin to Android and Kotlin on top of the JVM or the ART. This is just a look at a timeline. Kotlin was born in 2010, and up to 2017, release 1.1, when it became an official top-level language or first-class language on the Android platform. When that was announced at Google I/O, there were at that point 10,000, or sorry, that's a million downloads. I just had to read my chart correctly. So let's take a look at Kotlin. Why would we be interested in Kotlin when we can program in Java, a language that if you're on this call, you're probably familiar with? Well, there are a number of features that Kotlin adds that Java doesn't have. One, we talk about variables. Anytime we look at a language, we ask, how do we define variables? Kotlin provides read-only variables in a very simple way. We can specify, and here's Kotlin syntax. We use the val keyword for the value. My number is an int, and it has a value of 1. You'll notice right away that's similar to our JavaScript or TypeScript. If you work in those worlds, there is no requirement that statements end in semicolons. So here we have a strongly typed variable. Its type is int, and it's been initialized to 1. And this is a read-only variable. We won't be able to change the values. So it's like a manifest constant in Java. Here's another variant of that. And you'll notice something subtly different. We don't specify the type. The reason is the type is inferred based on the initialization. So since we've initialized it to an int, it is an int. So we don't have to do explicit type declarations when we're doing an initialization. We can also have mutable variables. So here are our immutable variables, or our constants, if you want to call them that. And here's an example of the mutable versions of those. We use the keyword var. Once again, we specify the type. For the first one, it's of type int. And for the second one, the type is inferred. Keep in mind that Kotlin, unlike JavaScript, is type safe. This looks kind of JavaScript-like if you've done much JavaScript. Since Kotlin is type safe, that value, the var, your number, will always be an int. You can't assign a different variable type to it like you could in JavaScript. If you've done a TypeScript, you can do the same sort of thing in TypeScript, but at the end of the day, your TypeScript variables are transpiled to JavaScript so they can still be redefined. So this is a higher level of type safeness than we might have in, say, a TypeScript. So why Kotlin? What are some of the compelling features of Kotlin? Again, borrowing or stealing from these other modern languages, Kotlin provides very concise syntax, and we'll see some really good examples of that in these slides. Like Java, it provides support for Lambda functions. It also has named arguments, default arguments, null safety, and interoperability. We'll talk about all of these. There are a lot of other things that Kotlin supports. Smart classes, sealed classes. Sealed classes are similar to Java enums. If you remember when Java enums came out, they followed the pattern from Joshua Bloch's book, and I can't remember the name now of his book, but the Joshua Bloch pattern for enums made enums very complex, in my opinion, in Java, as opposed to other languages. Kotlin has something similar to that called sealed classes. Kotlin supports delegation. In object orientation, delegation is an alternative to inheritance for building complex classes. Supports for functional programming as well. There are extension functions, lambdas with receivers. There's support for domain-specific languages. And if you're not familiar with a DSL or domain-specific language, that's domain-specific language as opposed to a general-purpose language. As an example, Kotlin or Java or C or C++, C# are all general-purpose languages. SQL or XPath are domain-specific languages. They only work in specific environments, specific domains, problem domains, what we're talking about. And coroutines provide support for multitasking. And there's a lot more to it, but we're going to focus on this list on the left. So as we've said, or as we've claimed at least, Kotlin is concise. It's not a very verbose language. Lambda functions, for example, are a built-in feature. There's no additional setup, and you can use Lambda expressions to easily perform operations on collections. Here's an example of a collection. There are 8 names that all begin with J. As a side note, I actually have 8 children whose names begin with J, and these are my children's names. So these are not just names pulled out of a hat. So we're creating a value list names, and we're making that names up of this list of names. So we get a list, and then we start using our lambdas. We say filter, and you'll notice the syntax that we use curly braces. Filter curly brace, and it says it starts with JO. The it keyword is used to represent the single parameter of a lambda function. So the filter takes each element of the array, and each element of the array is evaluated again as it. So the first thing the filter is going to do is it's going to go through the array and look for, filter out or filter those elements that begin with JOs. The names Jonathan, Joy, Joshua, and Josephina. 4 of them begin with JO. It's then going to sort by the elements of the now filtered array, which are just those 4. So the first one of those elements, let's see, in order the JOs would be JON, because N comes before Y and S. Then it's going to map the now filtered and sorted list to uppercase, and then it's going to iterate and print each element in the now filtered, sorted, and uppercased list. And what you get, the output from that is Jonathan, Josephina, Joshua, and Joy. So it's just a simpler syntax using lambdas and chaining. Again, if you're familiar, if you've done much in the JavaScript world, TypeScript, or other scripting languages, chaining is something we do very often in those languages, not so much a Java feature. So let's take a look at something near and dear to every programmer, every Java programmer's heart, and that's a POJO. POJO, the abbreviation stands for plain old Java object. But as a Java quote-unquote old-timer, I can tell you that what POJO really stands for is not an EJB. Not an EJB. The phrase came up sort of in response to the complexity of EJB, especially EJB versions 1.x. So let's look at a POJO, and we're looking at this in Java first. I suspect somewhere along the line you've written a POJO in Java. Here's a POJO called user. It's got two fields, name and age. We create a constructor for it, and actually a POJO, we might also have created a default constructor for it. We have the appropriate getters and setters, get name, set name, get age, set age. We have, to really create a complete one, we create an equals object that does a deep compare. It first checks to see if the two objects are the same object. It says if this is equal to the other object, then we'll return true. And then it's going to check the classes if they're the same type. And finally, we're going to do a deep compare and check the values. We're going to check the ages, see that they match, and see that the names match. So we've created an equals, we're overriding hash code, and we're providing an implementation of toString. Now, that's not really hard to do in Java. Many of our IDEs and tools, you simply create a class, give it two fields, name and age, and then you generate setters and getters, you generate a constructor or constructors from it, and you might even, in some tools, be able to generate some of these other things. But typically, we implement the overrides ourselves if we need them. In Kotlin, we simply use the keyword data. So we're saying class user takes two values, name and int, and we prefixed it with the data keyword. Underneath the covers, the compiler will generate getters and setters equals hash code, toString, and copies. So a complete POJO, and this doesn't depend on your IDE. You know, if you're using a modern Java IDE, some of the things in the previous slide were not very hard to do because our IDE could do them for us. But if you're using, you know, Nano on a Linux box or something like that, or a generic IDE, one that's not language specific in Java, you might have to build that POJO and build all its methods by yourself. Kotlin does this at the language level, not depending on the IDE to get this done. So a very powerful feature and simplification. Makes it simple to do this. Another feature of Kotlin, this one's really cool, is named arguments. Remember, in Java, the arguments passed to a method are passed by order. So the first argument is matched to the first parameter of the method, and second argument to the second parameter, and so on. So order always matters. That has an effect when we do overloading of methods in Java. If you recall, Java methods are overloaded based on the order, number, and type of their formal parameters. So let's take a look at at this class toaster, and this is a Kotlin class. It's got a function or method called makeToast. And if you're familiar with, if you're an Android programmer, you're familiar with toasts, you need a context. To make a toast, you need a context. You need the string, that is the message that's going to be displayed, and you can specify the length of the toast, not how long it is, but a duration. How long will it be displayed? So we have now this function, makeToast. So we next create a toaster, and we call it makeToast, passing in the context, so this parameter, hello, and the explicit length. And that function will make the toast and show it. So really not much difference, a little syntax difference than the Java version of creating a class with a makeToast method or function. Now, however, we can call the makeToast function using named parameters. The makeToast function takes 3 parameters in order: their context, message, and length. But now we're calling it, passing in message, context, and length in that order. Because the parameters are named parameters and we're specifying the name, the context is still this, the message is still hello, and the length is still toast length short. So we're allowed to do this using name parameters. Order doesn't matter when we specify them all by name. Further, we can specify a parameter without its name. This parameter is not a named parameter, or this argument. The length and message are. Important note, if you do this, if this parameter is positional, it has to be the leftmost, or all the positional parameters have to be the leftmost parameter or parameters. And if you think about that, that makes sense. So the first parameter is passed by position, but the length and message parameters are passed by name. Well, what about overloading? Because we said in Java, overloading is based on order, number, and type of parameters. Overloading is similar here, so we want some variations of the makeToast function. What we do is the toaster class is going to take a context variable. So the context is passed in, or context value, because it's immutable within the class. So we get a context. The first method here will use the context passed in and take the message and length. The second function, we can pass in a different context. So it'll use a different context, take in the message and length. The third function, we can pass in a context and a message. And let's see, I think we needed to define length differently here. I believe there's a mistake on that slide. The third one, we can pass in a message. To fix that example, Kotlin also supports default arguments. So let's take a look at this. And so if you're looking at the last example, you might have been saying, well, where did the length value come from in the last call? There's a typo on that slide. But here we're going to look at default parameters, and this will clarify what was on the previous slide. So here's an example of a function on create, and it calls super on create, and we call toaster we create a new toaster. Notice we don't use the new argument here either, passing into this parameter. So next we have toaster dot, and we hit control space to get line completion. And what we'll see is the variations of the make toast method. So that's the code completion here is just like it is in any IDE and any language. This happens to be, of course, Android Studio. We have the ability in Kotlin to replace all of the overloaded functions with this single function. And we do that with a combination of named parameters and defaults. So if you take a look at this, now we have our toaster class and we pass in the context, and our make toast function, there's only one. Its first parameter is context, and the default is to use the context passed into the class. The second parameter is the message. There is no default for that. And the third parameter is the length. And there is a default, length short. Then we call the standard toast.makeToast, context message length, and show. This is the function that could have been called correctly on that previous slide back here. Oops. So if you can imagine it, when you look at this slide, you can call this and pass in nothing but the message. If you do that, then the context becomes default and the length becomes toast length short. Or you can specifically override any of those values. So the combination of default parameters and named parameters is very powerful and allows us to do here what took some relatively complex overloading to do in Java. One of the things I really enjoy about Kotlin, I have to remind myself about programming Kotlin, is you can write Kotlin code that looks just like Java code, or looks almost like Java code. But I have to remember to use some of these features because they're not as familiar to me, being a long-time Java programmer. But it really does result in less code. So very concise, and combining default parameters and named parameters is a very powerful feature. Kotlin is also interoperable with Java. So that's one of the advantages, is that Kotlin can run on the JVM or on the ART in our Android environment. So we can use our Kotlin code from Java, use Java code from Kotlin. Here's an example of calling Kotlin code from Kotlin. So here we're just calling Kotlin code. And this is using the code from the previous example. We call make toast, and we pass in message equals Kotlin. So we're passing in a name parameter, and the context and length parameters go to the default, or fall back to the default. Now we can pass in a specific context if we want. Notice we don't have to specify the name for either the context or the message, because here they're being passed in order. The order was context message length. We're not passing a length parameter, the third parameter, so that third parameter falls through to the default. There was no default message. That wouldn't make sense for a toast, but there is a default context. And if a default parameter precedes a message parameter with no default value, which is the case, context has a default, message doesn't, the default can only be used by calling the function with named arguments. So if we want to use the default context, we have to provide a named argument like we do in the first call here, where we pass in the message, or in the last call, where we pass in the message and the length. Otherwise, we don't get, if we didn't have the named parameters being passed in, it would try to use hello again as the context. It would fall back and use order. So just a note, if you're not familiar with default, with default arguments or default parameters. So here's our example. This is a Java example. And our Java activity extends app compat activity. We've done this, if you programmed Android, you've done this a million times. And now we have our toaster class. We say toaster dot, and it controls space, and we get our code complete. And now you see make toast. And the make toast method here looks just like any other Java method. But this method is a Kotlin method. Remember, Java doesn't have default or named arguments. In Java, arguments are passed by order only. So the question is, in the Kotlin version, we were able to get away with quite a few variations in passing things. We could have passed in just one named parameter, and that would be message. We could have passed in all three or variants thereof. So in Java, do we have to pass in all three? Because if you look at the previous slide, the method make toast says it needs context, message, and length. The answer is, in this area, Kotlin really came up with some good ideas that make it easy to call the various Kotlin methods. So here's our Kotlin class, and we specify the Jvm Overloads annotation. Now you may say, what exactly does Jvm Overloads in Kotlin do? So we will RTFM, we will read the fine manual, as they say, so we'll check out the documentation briefly. So Jvm Overloads tells the Kotlin compiler to generate overloads for this function that substitute default parameter values. In other words, we're going to generate the appropriate Java overloads to make it possible to call this function in the various ways that we would have called it in Kotlin, to call it the same ways in Java. For, as the note says, if a method has n parameters and m of those parameters have defaults, m overloads are generated. And the first one takes n minus 1 parameters, second one takes n minus 2, and so on. Oh, what does that really mean? It says that the @JVM overloads annotation will cause the Kotlin compiler, as it compiles two bytecodes, to generate the necessary overloaded methods to make it look like the native Kotlin code. There are a number of other useful annotations that are defined: JVM field, to press wildcard's name, JVM static, a bunch more. But the point is that Kotlin also compiles the JVM. It's an option, but for Android, that's what we're compiling to, JVM or ART, Dalvik bytecodes. And they are completely interoperable with Java bytecodes. So here's our example, and this is a Java example, and we call the makeToast function. And here we see we've created the toaster, passing in the context, and we call makeToast, passing in the string. The string is a message, is the message, and Kotlin generated an overloaded function that takes just the message. Kotlin also generated an overloaded function that takes the context and the message. So generating these overloaded functions is part of what Kotlin does. So we kind of get some of the simplicity of writing the code in Kotlin, and we can still call it using our normal Java conventions. Pretty powerful stuff. Another feature of Kotlin is Null Safety. I used to do a lot of Java advocacy in the early days of Java, and I traveled working as a trainer and consultant for BEA Systems and Oracle, some of the big app server companies. And I was at an airport one day, and I think it was Minneapolis Airport, and I was looking at the screens, the flight screens, and I texted one of my friends, and I said, hey, the Minneapolis Airport uses Java. And he said, how did you know? How do you know? I said, well, all the screens have a null pointer exception on them, and there are little sheets of paper pasted over them that say, please see a gate attendant for questions about your flight. Not the best story from a Java advocate, but null pointer exceptions are a fact of life in Java. Java is not safe under null. We can have null values where we don't expect them to be. Kotlin provides null safety. So in Kotlin, which is strongly typed, we distinguish between references of a given type that can be null or not null. Nullable or non-null references. And you may say, well, wait, Java has nullable references as we move into the newer versions. True, but we'll take a look at how this works in Kotlin. It's actually pretty cool. So here's an example. It's a Kotlin example. We have a variable of type string. We assign that variable to null, and that's a compilation error. Because the string variable has not been, we haven't said that this variable can be null. It's a non-null reference. Think of all the times in Java when we've deliberately assigned a variable to null. You can't just do that to an arbitrary variable in Kotlin. In Kotlin, we use the question mark to indicate that this variable output is nullable, and then we can successfully assign it to null. So we can do some of the same things that we do in Java, for example, checking that a variable is indeed null and responding in some way. But that variable has to be allowed to be null and declared to be nullable with a question mark. Let's take a look at an example in Java using nullable. Here we have a method called sendMessageToClient. It takes a client, a message, and a mailer. Well, you have to have a client and a message. So if you don't get a client and a message, then we return because they're both null. Then we're going to get, if we don't return, we do have a client. So for the client, we're going to get personal info. And we have to check if personal info is null. If it's null, we return as well because we still can't send the message. Then from the personal info, we check the email. And if the email is null, we return because we still can't send the message. And from it, we say we finally use the mailer that we passed in. Notice we didn't check that it was null, but we probably should have, or we'll get, oh, I'm sorry, that was declared not null in Java. So we have a non-null mailer, and we call it send message function using the email address, which we got for the client personal info, and the message, both of which are non-null. So we did a lot of checks here, but this method is safe, at least from a null perspective. Kotlinized, it looks very different. In Kotlin, we declare that client is nullable and message is nullable by putting the question mark on the end. And then we're going to check the personal info. And the personal info comes from the client, which could be nullable. And then we check for the email. And the email or email address comes from personal info, which could also be null. But notice we haven't had to do checks here, as many checks. And then we can say, well, if we have an email address and a message, and the mailer can't be null, or we wouldn't have, because it's not declared to be nullable, we'd have gotten an error. We'll call the mailer and send the message to the email address. So it's this code versus this code. Again, not something you're going to do all the time, but it does provide you with much more concise syntax. And the goal all along is to make sure we can handle in these two versions, the Kotlin version and the Java version, that we can handle null values in a correct way. So that's what we're doing here in a simpler Kotlin mechanism. All right, so that's some things about the Kotlin language. The next thing we're going to look at is we're going to briefly look at Hello World in Android Studio, and we're just looking at a couple things about it. And we have to have our obligatory Hello World app, and we haven't seen one yet, so here it is at this point in the discussion. So we go into Android Studio, and we say create Android project, and you'll notice that we now say include Kotlin support. That was added in Android Studio 3. We'll specify that we're including Kotlin support. We're choosing a target. And we're going to choose the kind of application we're building. We're building an application with an empty activity. Again, if you've done Android development, you've done this a number of times. We give it a name, Hello K-World activity, just like we would any other time. And we're going to create a resource file, a layout file. So we'll take a look at that layout file. And we specify it just like we would any other. Remember, layout files in Android are XML. They're not Java or Kotlin. And here's that layout file. We're using the new constraint layout, and we specified the various constraints. But we've added, since this was an empty application, we've added this text view. And in this text view, I have highlighted something important. We have the ID. Remember, one of the things we do in any Android programming in Java is we're constantly within our views finding elements by their ID. You know, just a constant pattern. We find a text view or edit text and so on by its ID, and then we do something to it. So here we have the same thing, our layout XML file. When you include the Kotlin support, it enables both the Kotlin Android plugin as well as some Kotlin Android extensions. We don't use Butterknife. Butterknife is a library to let you realize the controls in a view. And you'll love this one. We don't need to make find view by ID calls anymore. I look back at I was just recently reviewing some Android code for an app I made for a company that manufactures tractors. And it was to allow a farmer, actually it's farm implements, like planters and so on, things you tow behind tractors. And it allowed a farmer to get out behind the vehicle and use his cell phone to start and stop some of the features of the implement for testing and observation. And I was looking back at that code for a client, and all the calls to find view by ID. You know, if you were to grep them in the project, there'd be thousands and thousands of them. We don't have to do that in Kotlin anymore, and I like that. There's support for a layout container in the Kotlin Android extensions, flavors, caching of Android views, parcelable support. Parcelable and parceling is similar to serialization in Kotlin. And there's other stuff provided in Android Studio for Kotlin. And this is a moving target. There are new things being developed pretty consistently. But as we finish up Hello World, here's our onCreate. The onCreate looks pretty similar, except the bundle is nullable here. We call super onCreate, which again looks just like Java. We set the content view and realize the layout, just like we would in Java. But now, instead of calling find view by ID and getting hello underscore k world underscore text view, and then getting back the text view and calling the text views method to set text, we simply reference the text view by name, and that is the name by which it was defined in the layout file, and we set the text property to the value we want. So again, it's not a huge thing, but it's something we do, something very simple that we do so often in Android and Java. We get a view, we get a hold of it, then we call a method and set some value in a view or retrieve a value from a view. You could use the same syntax to get the text, except the text would be on the hello underscore k world underscore text view.text would be on the right side of the expression. We can use that to extract the text value from a view as well. So no more find view by ID. And I tell you what, after writing even the first few Kotlin apps I wrote, I no longer missed, I didn't miss find view by ID. And what we get is an Android app with the text view set in it and the content of the view. So that's a brief look at Kotlin for Android. What are some of the reasons you'd use Kotlin? As we said, it's more concise code. It's still type safe. It's also null safe. It's, again, the more concise code, there are just a lot of things that we do in Java that are useful, but they're repetitive. We do them over and over and over again. And when I look for improvements, the things I do, I want, in the tools I use or languages that I use, I'd like to see that improvement happen in the things I use most often. So doing away with things like find view by ID, making function overloading simpler, those sorts of things make a very compelling solution, or make Kotlin a very compelling solution. And the added benefit is that we have full interoperability because they both compile down to bytecodes and or Dalvik by either Jvm bytecodes or Dalvik bytecodes, depending on your target. They both, Kotlin and Java, run together and are fully interoperable. on the Android platform. Some resources to look at developer.android.com. There's the Kotlin Getting Started or Get Started document that's very good. There's the interoperability guide, and very important, if you have an existing project and you want to add some Kotlin to it. This is I do a little bit of iOS development as well, though I'm a Java developer and Kotlin developer, not as much an Objective-C and Swift developer. But just like Swift came into the iOS world, and you have the ability to combine, take the best of both worlds, to use Swift where it made sense and use Objective-C where it made sense and use them together in iOS. We have the same ability to do that in Android, and to add Kotlin into existing Android projects and provide interoperability. There is also at kotlinlang.org a language reference, very useful and important. And I forgot to include the URL here, but there's also an online Kotlin Playground where you can write and compile Kotlin code. So if you have a simple syntax question that you're struggling with in Kotlin, when you're working in Android, you don't want to build a whole app and compile the whole thing and test it when you're going to throw the code away anyway. Fire up a browser, go out to the Kotlin, I call it the Playground, and write a little bit of Kotlin code there and test out the syntax. When I was first learning Kotlin, I found myself doing that quite a bit, just to very simply within my browser throw some Kotlin out there and make sure the syntax was correct. Any questions as we finish up? So sort of a high-level overview of Kotlin. Kotlin is a very powerful addition to our toolkit as we build Android applications, and you'll see more and more Kotlin in the future. I especially like the fact that I can add Kotlin features to my existing Android applications. So it's not an all or nothing thing. You can freely mix and match the two. You can expect to see Kotlin training from WebAge Solutions, that we'll be adding Kotlin into our Android course, sort of a brief introduction to Kotlin. And also in the future, I would expect that we'd see specific targeted Kotlin training on Android and possibly on the other environments in which Kotlin runs. So thank you very much. As I said, my name is David Chung with WebAge Solutions, and feel free to contact us at webagesolutions.com/contact us, or you can reach us at our US or Canada phone numbers. Thank you very much, and everyone have a great afternoon. And we'll be signing off the webinar here in just a minute. Thank you.